During this short how-to video on how to perform protein normalisation using Genesys image capture software and gene tools analysis software, you'll be shown how to 1. Activate a stain-free gel before transferring to a membrane, 2. Catching an image of your membrane, 3. Catching an image of your Western blot, 4. Protein normalisation in gene tools analysis software. Western blot normalisation is used to measure changes in the expression level of proteins against a constant protein level, which can be a single housekeeping gene or total protein. Stain-free normalisation uses total protein as a constant protein level. When you open Genesys software from the icon on the desktop, you will see the home page. From the home page, select Gels and Stain-free Gel, and then 1 minute incubation. 1 minute activation provides sufficient UV activation for gels used in Western blots. To ensure maximum resolution, use a sample size pop-up to select your sample size to ensure the sample fills the screen. For this example, we will select 13.3 times 8.7 centimeters. Don't worry if you select the wrong size, you can always adjust the zoom later. Place the gel on top of the UV transilluminator in a central position. Adjust the iris and the focus using the lens controls. If you have a particularly bright sample, you may need to close the iris a bit to help with focusing. Focus the image until the edges of the gel are nice and sharp. Press the capture button. This will initiate the incubation period for the time chosen, and then the software will capture an image after the incubation period. To save the image, select the save icon from the pop-up, and you can edit the file name. This will save the image in the SVG format. The SVG format is a fully GRP compliant format that ensures image and data integrity, essential for ISO 21 CFR compliance requirements. If you prefer to save your image as a TIFF or JPEG, then use the Save As icon. To export your images as displayed or as captured, you can select the DPI and the bit depth when working as a TIFF image. The gel can now be transferred to a membrane. Once this has been performed, select Blots from the home page, then select Stain-Free Blot. If the gel frame, the blue-grey border, is not visible, select Gel Frame from the grid button in the bottom right corner of the viewing window. Align the top left of the blot with the inner top left corner of the gel frame. Press Capture and the blot will automatically be captured under UV light. This is the first stage of the multiplex capture. The membrane should now be probed for a protein or proteins of interest using chemiluminescence reagent. Once you are ready to capture your chemiluminescence blot, select Blots from the home page, then Chemi Single Image. Select Custom and then enter 13.3 times 8.7 in the sample size pop-up. Position the blot as close as possible to position it was in when the stain-free blot image was captured. Use the gel frame to position the top left corner as previously. Use the slider bar to capture a faster speed or a higher definition. If you select faster speed, this will involve more binning. Binning combines adjacent pixels to form superpixels, but will result in a reduction of resolution. If higher definition is selected, the capture times will be longer, but the resultant image will be of publication quality. A good compromise between speed and quality of image is to place the slider bar in the middle. Press capture and the blot will be automatically captured. To form the multiplex, you will need to use the View Images screen. From the home screen, select the View Images icon. Then select the image of the membrane taken under UV light and the image of the Western blot. Then select the multiplex icon to form a multiplex of the two selected images. A window will appear with the two images overlaid. Leave the type of composite as colour and press OK. Do not worry if the bands do not exactly overlay. Analysis can be edited for misalignment if necessary. The two images will appear in a group under the new title, Image 6. Press the Save button to save the images into a single SUD file. Select the three images from the list and browse the save location, then press Save Selected. The image is now ready for Western blot normalisation analysis in Gene Tools. From Genesys, you can send the image to Gene Tools using the Gene Tools icon. Or you can open Gene Tools from the desktop and select Open to select the image. By default, the composite contains the stain-free blot capture from Genesys. The sample type Western blot normalisation will be selected. Adjust the red rectangle on the image so it just surrounds the bands and the lanes. And press OK. Gene Tools will automatically attempt to locate lanes and bands in both images. Gene Tools will also assign a normalisation channel to the stain-free blot and assign lane 2 of the stain-free blot to be the normalising lane. Select to view the Chemi blot image. In the results table, you can see a column entitled Normalisation Factor. This is the figure used to normalise the quantities attained for our proteins of interest. Each lane has a different normalising factor dependent on the ratio or the total protein in that lane compared to lane 2. Select the first band in lane 1 and press the Assign Quantity button and enter a quantity of 100 and press OK. The results table will now have two new columns, quantity and normalised quantity. The quantity will be the value you have just assigned, and the normalised quantity will be calculated from the quantity and a normalised factor. In the case of lane 2, band 1, the normalised quantity is 93.9. Switching the selection to lane 4 shows that while the quantity is considerably smaller, the normalised quantity remains high. This is because the normalising factor is increasing from left to right on the blot. This in turn is increasing because the total protein in the same free blot channel is decreasing. You can export data to Microsoft Excel or to Microsoft Word.